Hello and welcome. Good morning, good afternoon, and really happy to see you joining here for our webinar today. So my name is Christian Heidkamp, and I'm going to be your presenter primarily throughout the next 45 minutes for this webinar on monitoring the IBM Power ecosystem using Microsoft Azure. And with me, I have Sigrid Rupieta. Can you hear me? Can you quickly say hi and introduce yourself, please?
Yes, thanks, Christian, and hi to everybody. My name is Sigrid Rupieta, and I'm here the technical director at NiCE, trying to oversee the technical processes at all levels.
Wonderful, thank you. Great. So we're actually going to start with a short overview of our agenda, which we're going to cover. So first, we'll actually start here with an overview of Microsoft Azure and Azure Monitor. So we have a lot of new signups here, which haven't previously have not used our products and not so familiar eventually. So we thought of giving this a bit of an extra spin to actually introduce a bit the Azure's environment and Azure monitoring ecosystem. Then we talk a bit about how we set this up in a hybrid environment, like with some parts from the IBM Power infrastructure on-premise or like in a hosted on-premise environment. So, and then on the Azure side, how we build the connection, how the networking is done there, how things go communication-wise. And then we get in the third bullet here to put a primary announcement here. This is also a release webinar for new versions of the agents for AX, Linux on Power, and Linux as well on zLinux. So that we'll be covering. And then, well, obviously, we always have a live demo and keep fingers crossed. We've been working in the background all morning already to get that flying. So we're ready. We can show you the demo. And then my colleague will also dive a bit into the source code and how we build things and other details around that. And then we finish with one more thing. So I'm not going to talk about that yet. So you have to stay until the end to hear what that will be about. So, all right. So, and yeah, one thing which is important. So this session is going to be recorded. So if you have questions, please use the Q&A or chat. At the end, we have a Q&A session. So if you want to open your microphones, we can do that at the very end. So just want to give also those to listen to the recording, so also welcome to you listening to the recording, the opportunity then to enjoy the content. Just a very few briefs about NiCE. So NiCE IT Management Solutions is headquartered in Germany. So that's also where I'm located. And there are colleagues from many parts of the world to join. So also colleagues from the United States also here and with the partners and clients, thank you for joining. So we have a global customer reach through most continents, and we are really building monitoring software. So and we're providing services, but the key is here building turnkey software you can use out of the box. And yeah, without operations in US and EMEA, we can cover the large client base. We do monitor, really we're building like integrations, right? We don't have our own monitoring products, so we're building either on System Center or Azure Monitor to integrate the third-party workloads, primarily where Microsoft leaves gaps, so either it's the VMware space, Oracle, Linux, or even like Citrix or like more exotic systems like we have today, like IBM Power, which is definitely a niche, but it's a niche which is it's good to be in because we've got like large clients that rely on those IBM Power infrastructure and at the same time have a global monitoring strategy that's driven by their platform on Azure or in the System Center. So we need to basically provide those integrations. Further, we have Microsoft 365 on here. Well, if you ask, does Microsoft not provide M365 monitoring? Well, it does to some extent, but it's typically the best if you have a third-party vendor like to monitor what Microsoft actually does there. So if you're using Microsoft Teams or Outlook, Exchange Online, so we basically have a solution for that does that from an independent point of view to measure the SLA for that. But enough for that. So I'll actually start right now to actually dive into the Azure monitoring area. So Azure basically is a whole pot of different services basically that comes in there. So, and the Azure Monitor is one which everybody uses Azure. And it's sometimes used, sometimes not used, but it's basically part of every subscription. So, and the Azure Monitor consists of a number of places. So you have basically your data sources. So data can come from application workloads, from the infrastructure. It can come from the Azure platform, or can come from custom sources. Basically, you can bring the data, either log-based or metric data, into the data platform, which is basically here the middle column where you see basically your data platform, which is here. So and there are different parts. So the first one is the multiple dimensional metric store. So you have the MDM. There you see Prometheus as an option, which just been recently added, and we have basically log with log analytics. Traces and also changes we can capture. And at the bottom, we have the managed instance of System Center that basically complements this as a ready-made solution to actually use agents and bring also data in there. On the right side, we have a number of services that consume that data from the data platform. So we have application insights, which really around if you have application to dive into the details of the application, container monitoring, VM insights, we all call it network insights, and so on. So we only will touch point a little bit on that, but not going into depth. The visualization is there's something called workbooks. I'll touch a bit them later. We have the dashboards while using them. There's Power BI, which you might be familiar with, and Grafana. Grafana has been really only recently added. So Grafana is also possible at the bottom here. So Grafana is important for the strategy of visualization at this point for all the data that is within the data platform. The analyze of the data is really around log analytics with the KQL, with the Custo query language, basically you can use for querying the data, and the metric explorer where you have access basically to the metric data. So we will look at this, and when I do the demo a bit later, we'll look at the metric explorer, and then we have change analysis to understand changes in the infrastructure that we keep a bit aside today. And yeah, for the respond auction, that's also not part of the session here. So obviously, it wouldn't be anything if you can integrate with. There are a lot of things you can integrate with Azure Functions, and you see the different options here. So also the event up is quite popular. So yeah, that is basically the other part. So what we really look right now in more is two parts. One is the log analytics piece, and one is the SCOM managed instance. SCOM stands for System Center Operations Manager, which is basically in an environment where you also run this on-prem as like a system center monitoring product, which is like really the enterprise monitoring product for hybrid workloads and on-prem since I say 2008, 2009. So, and it's built around the SQL database, and here in Azure we're using a SQL managed instance, and then we have all the workflows here with the operations management console. That is a full console to actually see all alerting, performance graphs, have the different views, and also the dependencies between the different objects that are discovered. So let's continue and drill a bit into the managed instance. So if this has been rebranded so as like a System Center Operations Manager managed instance, part of Azure Monitor. So it will evolve over time into Azure Monitor more and more. It has a connection into the log analytics workspace as well. So data which goes basically in the SQL managed instance then also goes later in the log analytics workspace here. So but as we have the architecture today, and when we look later at the demo that we have, really like a piece which is the management servers. So these are IaaS VMs basically deployed in Azure VMs, and they can basically scale, do horizontally scaling for scale out workloads. So you can just like scale it out for thousands of systems to be monitored. And that makes basically up this SCOM managed instance with the portal UI and the console in front, and and then you have basically all the agents here which are around. So the agents can sit within Azure, they can sit within another hyperscaler environment, they can sit in on-prem environment. There are something called gateway servers, so you can place the gateway servers in different networks. So basically making this a complete monitoring solution. And again, today we really talk about where are the gaps, because Microsoft does not provide an agent for AIX on that, and also not for Linux on those platforms of IBM Power and mainframe. So that we'll actually cover here in this session today. All right. Just looking out if there are any questions. So feel free again, if you have questions, just type them in and we answer them as we go or at the end. All right, so here we have a quick overview. It's from the network architecture. So we have the Azure part and we have an on-prem part. So this is typically how this is the blueprint setup you have. It covers, you can go up to 10,000 different systems or even more in the different environments. So you can even connect more environments to that. So, and you can use gateways. So you can either use a site-to-site VPN, which we here use between the on-prem environment and the Azure environment, or if you're using ExpressRoute, that's also an option, which is more like the enterprise scale option you can do, and which in our case goes to a VPN gateway. So we have like one network and a couple of sub networks. So one for the managed instances, the SQL managed instance, and then we deploy the SCOM managed instance, and then within the SCOM managed instance, we have the so-called management servers deployed, the virtual machines that actually do the workload. So you can have a Linux system here, or wherever. You can also have the Windows boxes. So one important is here, you see on the left side, the Active Directory or the directory server. So even if it's called like the Azure SCOM managed instance, it requires an on-prem AD, so it does not work with Entra ID, so which is was previously called Azure Active Directory. So it's now Entra ID, and but we need the Azure Active Directory basically on-prem because it's real hybrid. So it all the systems that appear here basically use that directory also to authenticate, for example. All right, so that's basically the overview of the environment. So we have added like an additional gateway, which goes out to different environments. So we have, for example, a virtualized VMware environment with vSphere sitting in another environment. So we can actually pull that in as well there. So it's really the idea to do hybrid monitoring, multi-cloud monitoring from within Azure. But again, it could also run on Amazon AWS, right? So it's because it's a management server. You can also deploy that in another IaaS environment. There are a couple of servers for Azure Monitor in specifically who actually have additional features that come in, like, for example, the connection to the log analytics workspace that are obviously available in Azure only. Okay, so with that, actually, I'll take a step forward now, so we understand like how the environment looks, how Azure is set up with Azure Monitor, and now we actually have like a IBM system P here, a Power system, S1022, 922, Power 9, Power 10, Power 8, what you have basically. And we have the logical partitions, the VMs, the servers sitting on them. So we can have like an AIX system, a Linux on there, IBM I, any like those basically. IBM I is a specific use case. If you have them, there's also an option we could talk about that. I didn't make it part of that presentation, but basically let's take it as AIX system, and the AIX system, we actually want to do real agent-based monitoring. So we actually install the agent on the AIX system, and the agent is a full agent. Basically, the agent is passive, so it's actually triggered by the Azure Monitor with a request from the management server of the SCOM MI, and it actually goes out and requests by port 1270. Like, for example, I need the CPU utilization basically, or memory or disk, or you can also use process monitoring. We're doing NTP. I've got later the list open what all options you can do. You can also do custom monitoring. You can execute scripts. This is all done in a very confined and secure context. So the agent is basically protected and can't be abused for anything else than with the security credentials you provide is these workflows run as a non-root user, and can talk about this a bit later. So there's an extension, we call this management pack. Basically, the management pack contains the information to extend with custom monitors, the monitoring. So we have one that is added. But if you, for example, have an SAP environment or an Oracle system running on that AIX LPAR, so you can put like additional monitoring on top to monitor this as well. So you really have that perspective from the agent, so the complete component monitoring in there. So, and then basically the data is stored in the SQL managed instance. This is the Windows VM that basically does the monitoring. There's something called the health service that triggers this, and the communication goes over Windows Remote Management, which has its implementation in the on the side as well in the component for the AX agent. So that's about the architecture here. So how this is set up, and then we have these providers, so memory, CPU, disk, and as I mentioned, I will show you later in the demo, who collect actually the data. So what do we monitor? So obviously we want to make sure the AX LPAR is available and running and performing. So we do actually do like process monitoring and the network adapter monitoring. We can do the log analytics. So instead of sending all the logs, for example, to a log analytics workspace, we can actually analyze them on the AX system itself and filter them and decide what to do them right in that time, instead of like uploading like tons of data to another place. So that is a great option to do, and it provides the pseudo support. So for example, if you on a certain interval basically want to run specific commands and see what the output is, so you can do that. It's basically much more powerful than cron. So because you have like a central console where you can configure this across like let's say even thousands of AX boxes. So we have clients with really over 1,000 AX LPARs that are monitored within this environment. So they have a central place where they can use grouping to run certain workflows, and then take the return value and analyze this on a large scale. So, and it is really like great to have this central place where you can administrate it and run the operation from. There's some additional monitoring features, so which is the NTP certificate monitoring, so the LPAR frame. So for the physical CPU as well, if you have logical volumes in stale state, we do something called a read-write test. So basically to really make sure that the mounted volume there is read or can be read from and written to. So it's kind of writing a test file and doing kind of probing if everything works, and then really get assured that this is working, and then the volume groups are also in there. We have process monitoring here, but that can be extended, so it's really easy to customize. So and if there's interest, I can show you this in a moment as well in the demo. Well, now we come to the new release. So we've been working over the first months of this year to get support for OpenSSL in there, 3 in there. So it was quite a journey, I'd say, but it's released, it's tested. So, and we increased the base agent version, and we've added some documentation. So documentation is really key because we provide this package as is to our clients, and they can basically do it on their own. So we have the idea not to provide consulting with that. So it's basically you take it and have all the documentation and work with the product. And then we've added some security updates in there. And there's some new license administration feature in there to have the licensing of the agent, basically, which is part of the management pack in there. So if you see MP, it's a management pack, and the management pack has the agent combined. So it has like a template that goes into the System Center Operations Manager with all the monitors, the performance counters with the performance collection rules, the alerting definition, discovery, and on the other side, basically the agent where all the work is actually done. So that's about the AX management pack. So you have to wait a couple of more minutes before we get to the demo. So I'm just going to talk about Linux as well, but here is the support metrics. It's available on our customer portal. So where we actually define what versions are supported. So we go back to AX 7. And 7.1. So, and well, you see, it's basically all the combinations are supported here, which either you have a System Center on-premise, or if you're using your Azure Monitor for that, it's basically supported. Yeah, there's also other older OpenSSL versions supported. So, yeah, and this gives you basically the overview. I can go over this a bit quicker. Now we actually go from AIX to Linux on Power. So we call this the Linux Power Management Pack. Again, it has the agent component here on the right side. On the left side is the NiCE Linux MP. That isn't 100% correct. Should be Linux and not zLinux, but zLinux is the other one which runs on the mainframe basically. And then it is the same architecture. It's the same agent, just basically built for a different processor architecture on a different platform. Yeah, it basically gives the same architecture here, and collects the data, brings it to the operations management, and then the data can be brought either into the log analytics workspace of Azure, or it can be evaluated right in the SCOM environment. We added BTRFS support. It's all open source, and we talk about this in a moment. So where this comes from and how we maintain that. Also, it does the secure approach, so you can basically minimal permission approach. So you only give the permissions you want them to give, and running the scripts only you want to be run as a super user via the sudo option. So yeah, you can put further management packs on top. So that means if you have a management pack already for the x86 for Oracle, you could also use that the same way on Linux and Power. Also here we do actually have an overview of the Linux distributions we support and versions. So it's SLAS and Red Hat basically. If you have an Ubuntu, that's also an option, but yeah, that can be done on request. So it's like just to keep our effort in a range when we do all the testing and certification to keep that to a manageable level, I say, because we actually test every combination. So we have Red Hat, we have 8 and 9, we have SLAS, so really making sure that this is working and supported. And for those who submit support calls, we actually can easily look at the similar system here. For zLinux management pack, this is basically the management pack that's run in the ZVM on a mainframe. So it's a very niche product. There are only a couple of customers worldwide using that. So I'm not going to go into details. If you want to have more information, then please let me know. All right, now it's time for a demo. So and let me just switch to the demo environment. So. All right. I'm actually going to start with the Azure portal. So and start at a rather high level. So for those who are not so familiar with Azure, so we have on the one side the SQL managed instances. So we have basically the data store for structured data, which comes from the collected data, from performance data, which is being collected by all the agents, which is stored into the SQL databases here. So we have two databases. Basically, it's a standard database with more near-time data, and we have a data warehouse where up to 400 days of performance data can be stored in, which are in a structured data. So that's one of the SQL managed instance, which is it's basically provisioned, maintained. You don't need to do anything. It's basically a really managed environment, it's a managed database, so to say. And then on the other side, we build on top the managed instance for System Center Operations Manager. So that's also basically deployed, and we have here, that's when basically the deployment is completed. So we could, for example, look at the underlying infrastructure. We have a scale set. So there, in the end, the virtual machines are running in a scale set, and these are the VMs basically are referred to as management servers. So in these management servers actually do the workload, like running the workflows, collecting the data, connecting to the agents, and bringing the data in. So and then the visualization can then be with Power BI or Grafana, or we can connect, if you go here, basically with the operations management console, and that will actually do. So our name is the SCOM MI 246. So that's the 246 managed instance. So I'll actually go here, connect to this load balancer. So this is basically the load balancer is defined. I'll show you as well here in the infrastructure. If I can find it, it's actually moving around. It should be somewhere here. So it just puts the DNS name right here. So you can just either take the DNS, which resolves to the load balancer. So I'm just going to go here just to make sure, because it actually looks exactly like the on-prem version. So we're just connecting to this IP address. So, and it's really like, you can't tell once you started this up if it's like the on-prem version or if it's the version that is that's actually on the managed instance. So let's wait. Okay, it's basically the same as here. So it's this SCOM MI 246. Yeah, let's wait until this connects, otherwise we continue here. So, all right, so we have here, basically this is the operations manager console. There's a web console as well. So this is more like a fat client, which you can install also on any system, basically connect to that. And we do actually then have the state view for the AIX system. So we added one AIX systems to this here. So this is, you can see it's the PowerPC architecture. We have the version number, we have a host name, and a couple of details here. Then the really powerful feature is basically the discovery. So if you go in there, it does a discovery and goes out and discovers basically what's on there. So it basically finds the operating system, it does find the network interfaces, it finds here, for example, the root VG, like the volume groups. It does the LPOF frames, it discovers, and a couple of other things right here which are not fully monitored, like the different file shares here, for example, that are on here. And then we can go, basically the health rolls up all the way to the top. So here, if you go here and say, well, I'd like to understand what's the health basically of this now. So actually we can go in here, do a refresh, yeah, and we actually see a couple of monitors that are loading on here. So all of them, they are, yeah, I think the only real one is this one, because the root directory basically runs out of space. So and we can just switch over here, and then we can actually see it that there's the space runs out on the root volume group, so on the root man point. So and if you would like to, for example, to see the performance graphs, so we can actually go here, and we also have the performance graphs here at hand. So we have the processor performance, look at the memory performance, swap utilization, and others. So basically the typical monitoring you have. So, but besides that, obviously you have the additional monitoring, I think, which we should see here. If we uncheck that, so basically we get like all the monitors in here which are available. So some of them like are, you see, for example, the disk free space is disabled at this point, because we rather prefer like to have this in percentage than an absolute free space. And you see like different, you could enable like process monitoring here for different processes, and yeah, the apparently that's not being configured. So actually in that case, it gives an alert. And also for performance, we can look at operating system performance here, where we would actually see cron, or if there's certain instances for the for processes are missing, or if swap space use is full. So this is basically a set which is provided out of the box. But if you want to add something to that, it's pretty straightforward. So yeah, I'm not going to go into all the details, but there is the option basically to extend on that. You can see here we provide a couple of additional information. So they give links basically that provide additional information about those monitors, and really should be like a hands-on set to get started with. If something should be changed, let's say, for example, the percentage of inodes free should be monitored in a more frequent interval. So this is possible to do where like an interval. Currently we do 5 minutes interval, so 300 seconds at this point. So that could be changed, or then also a threshold. So if only 5% of inodes free, we get like an alert. So and this will be a critical alert. So but that all can be customized here. Again, tying back to that point, if you have like a lot of systems, you can make groups of systems, let's say application A, B, C, and then place those systems or even those volumes in that to actually have the correct threshold applied. All right, so that's the part for AIX. Yeah, before I go to continue, I will actually do the Linux part here. So the Linux system, we have one Linux system in here. So that's actually that you see also the architecture. It's been discovered here. Just a moment. There you go. Yeah, so here we have the architecture, so PPC64LE, which is running on the IBM Power environment. And here also we discover a logical disks here again. We have the network adapters. I'm going through the state views now, basically. And we have the performance data collection. So this been just set up, so there's not going to be much data. So it just starts basically writing the performance data in here. So, but what I can show here, which I just didn't show on the other side, is that we have the options to run something called task on the right side here. So for example, if you would like to get an immediate view on the top 10 CPU processes, for example, we can just go in here and run that task. It will execute this right now on the system and return the top CPU consuming basically processes that are running on the system. So similar to VM stat execution, or if you like to execute something else, like even custom task, you can do that right away on the system. So running memory information, so we get the memory information, and that's a really good tool to do right away before logging into the systems. And even if there are like a number of systems on there, you can select like 10 systems, run it, and get the information from all systems. So that's that part. So as well. Right, let me close that down. So that was like a first part of the demo. We're going back to the demo in a moment as well. So, but now I will take a break. And I will pass over to my colleague, and we get a bit to the meat behind that, like how do we build this, and what are the sources. So Siegfried, if you hear me and here, and then you please take over and talk a bit about the sources in the build process.
Yes, sure. Thanks, Christian. So we'll see in a moment then which sources we are using, where they are coming from. We'll have a quick look at our build process. And the last one topic, a little bit about how we are going to incorporate changes and updates should they be necessary. Okay, next slide, please. So sure enough, we are building on the original sources, which are the base for every SCX or Unix or Linux agent. So it's the same code. It's the original code which Microsoft uses for all the supported architectures supported by Microsoft. We're taking this source from GitHub. It's open source here. transporting it to our environment. So we are keeping our the sources then on-prem here, and are making our changes here to these base sources, separate branches, of course, so that we are able to see the differences and being able to incorporate changes, later changes, or security updates, for example, easily into the code stream which we are using to provide the agents for these three architectures. So we are basically managing, adjusting and adjusting the build scripts, the build processes, and all the necessary changes or areas in which the architectures, which are not yet supported or not supported anymore by Microsoft, differ from the Microsoft supported architectures. We are trying to keep those changes as minimal as possible, so to keep the differences minimal. That makes it easy then to incorporate later changes easily to our code stream. So next slide, please, Christian. Building. We have a hybrid build environment here. We are using a customized build process, not the original build process which Microsoft uses in the open source. So we keep our repos here on-prem. We have our Jenkins server in which we implemented the build pipelines. We have a couple of systems running here on-prem, which are used for build and for testing. But we are also using systems in the cloud. For example, for the zLinux systems, it's not on-prem here. It's a system in the cloud, as well as other systems. They are connected via tunnels or VPNs. Depends on the system which we are trying to reach. But all these builds are then centrally controlled, centrally managed by our Jenkins server. And we all start the builds as usual from the centralized points. The sources are not kept on the build systems. They are just pulled then when needed. Compiler or the build scripts are then running and compiling and crafting these agents then, which are then stored in our on-prem environment on our servers where we have the binaries and all the artifacts. Okay, then the next slide. Yeah, incorporating changes and updates. Which updates, which changes? Mostly security updates. We are monitoring several channels here to get an alert, an easy early alert. Whenever a security issue is seen brought to the public, we are monitoring, of course, the original code streams on GitHub from Microsoft, new agent releases. We are evaluating then, should the changes be incorporated and in which time frame should they be incorporated. If they do, then we are merging it to our NiCE repos, starting our build pipelines, or that kicks in automatically then, and we are executing our test cases in the NiCE lab. That's a big point here. For all these changes of all these agents on the architectures, on the three architectures here, we have test cases, and we are executing these test cases before we are going to release our builds. If a new build then is available, we are notifying our customers, and delivery is done via the NiCE portal, so you can easily download the new builds then, or the new agent packages from there, and using it then in your environment. So that's our approach to keep up to date and incorporate mostly the security changes, as I said, but not only security changes, also new releases, for example, new features should they appear in the original code on the GitHub open source directories. That's basically it.
Perfect. Yes, Siegfried, thank you very much. So for going through that. It is really part of our support promise, I say, right? So, and because those clients who actually use our products for AX, zLinux, and Linux on Power, they really need the certainty that somebody can quickly resolve problems or security threats that are coming up, because typically these systems are critical systems that are monitored. So in case there's something there, and we basically provide our 24/7 support or 9x5 support for different time zones to actually help to resolve eventual problems. On the other hand, we also maintain a large environment to maintain like different IBM Power systems, which you'll see in a moment when I come to the next point. All right, so in the beginning, I promised you actually that we're going to go for one more thing, and I think that is really like the thing I wanna talk about. So, and it's now going a bit away from the SCOM environment, because the SCOM is still a managed instance part of Azure, but we could also go a step further and bring the data somewhere else. So what we actually, there are two parts which are new, and I'll show you the slide. So it's an architecture slide, and on the left side we have the HMC. So, and the HMC obviously is a bit the piece we haven't shown. So we have shown the AIX, we have shown the Linux on Power, right? But still, there are the IBM systems underneath there, and we somehow want to have some visibility in there. So, and that's the piece which has been missing in the puzzle. So we actually bring this in here, and including the virtual I/O service, which we can also monitor over here. So, and there are two approaches. We can either give the data into the SCOM environment via management pack, so that's also soon going to be available. So it's a pretty sneak preview basically, so that we're going to release in the next couple of months an HMC management pack, which is capable of basically monitoring the HMC with the systems, with the IBM systems, with the VIOS, and basically other things that are connected to that. But there's something else new, because on the right side we actually have the Azure Monitor with log analytics. So, and in this case there's no system center environment on the slide anymore. So, and we're taking the data which comes via the HMC REST API and putting it way through into a log analytics workspace. So, and that's what I'm going to show you in a moment now. So, and the parts which are key for that basically sitting on we call it collector VM, which are basically those two components. One is the HMC collector, which basically is a REST API client for the HMC REST API. It has the HMC viewer role, user of the HMC viewer role, so limited permission. It basically pulls the data, and then it takes it to the NiCE cloud connector. The cloud connector is basically an application that hooks up through the integration capability into application insights, and then into log analytics workspace. It's very similar to using, for example, ingestion pipeline on Azure. So, and that's the demo I want to show you now. Let's switch back to the system. All right, so we go back to Azure. So we're back on Azure now, and we're actually going to the log analytics workspace now. Log analytics workspaces. So no, I don't want to go to this one. Here. No, just a second there. So I think we have to pick a different subscription. This one here. There we go. All right, so this is the log analytics workspace, which resides in a paid subscription. So the data goes basically into tables. So, and the data is basically ingested and stored into in tables in here. So there are a lot of tables, so where all the different data can go in. But we basically have an app table, so we can actually go in here into the metrics, because we have the metric explorer. When you think from the beginning, I showed you different components. So one is the metric explorer. So we can actually go over here, and we store this in the Azure Monitor component here. And now we actually have these custom namespaces basically. And we have a namespace here for actually HMC managed systems. So and now for the HMC managed systems, for example, we like to understand the CPU. So now we get one communicated graph. So we have to apply splitting, and the splitting is done by managed systems and connection labels basically. And now we get basically the data from the HMC in here. So you see like the first one you have a label of, which is like a Power 7 system. Then we have a Power 8 system and Power 6 system. So no Power 9, Power 10 in this environment, but we just took some of the older system just to prove that we can go back in time as well. So obviously Power 9 and Power 10 is similar supported. There is VM virtual HMC. We're using virtual HMCs here. So and from there we basically get the data, and we can just see, for example, well, there've been a little spike, so we can actually go up and see, well, that's the CPU usage at the Power 6 system went up to 7. So we have basically all the data now available right here from in the Log Analytics workspace without putting additional system center components in there. And from here we could actually say, well, I would like to have, for example, an alert if my Power 8 systems hits like a 90% CPU usage, or we could like pick like another one, like let's go here and look for example, the available memory. So which would be this one here. So one system is full basically, the others still have available memory. We could also go to the virtual I/O servers. So if you go to the virtual I/O servers, it basically pulls the data. So we have the partition state of the virtual I/O service, again looking for example at memory at the VIOS service here. So which then basically gives us this data here with the utilized memory. So we have one of the Power 7 VIOS system basically is using 86% of memory. So we could say, well, actually, like if it's hitting a 90, I'd like to have an alert. So you basically can go in here and create like an alert signal basically for like a threshold of 90, and define the check interval, and then go basically next and define some actions on that, what should be actually happening in this case. So this is basically the way you can actually customize the monitoring very easy. It's low impact and important. It has only the data you need. So in many other cases, a lot of data is pushed into Log Analytics, and well, all Log Analytics is not free, so you have to pay money for the data you store there. So, but you have a very good control over the frequency you want to put the data in there. Plus, you have the option also to define the retention. So, as I said, this is stored in tables. So right now we put this into the app metric table. So, and if you like say, well, I don't want to have it 120 days, I would like to have it for a longer time period, let's say like 180 days. So basically I can store the data here for a longer time period right in here. So yeah, so that's the thing, which is I think is really cool. So the HMC data has been missing in the past. Now we bring this in either with a management pack, or you can have the option to bring it also directly into Log Analytics. You see here in the Log Analytics workspace, we have also System Center in here. So that's basically when you connect your management group into the Log Analytics workspace. It's a rather lengthy configuration task, because you want to define what data should go in there, because otherwise it gets quite expensive quickly, because there's a lot of log data eventually going in there. So I haven't set it up for this demo here today. So with that, I'll come to the end of the demo. Let's see, where do I go back to the slides? Yep. Yes. So basically, with that demo, I conclude the session for today here. So, and I'm just checking if there are some questions. I have one question for Siegfried actually here. So do you do changes in the code that are worth to contribute back to GitHub?
Currently, we have not decided to do that, or whether we should do that. It's up to the future. But
Okay.
I think we will make up our minds then.
Okay, good. Are there any other questions around? See? No. So in this case, I actually thank you all for taking your time, spending here with us, also for those who listen to the recording. And if you have any questions, feel free to reach out to you. And I wish you good rest of the day today. Thank you and goodbye.